All right, so we're looking at lesson 3.5, and specifically, we're going to start in this 3.5b now, which deals with domain and range. Now, before I get too far into this, we all understand, we've all seen domain and range from the last video. Domain is the set of all inputs. Range is the set of all outputs. But I wanted to take a minute to go back to what we did in the last video and talk about a little notation, all right? Because this section and the next one, it's critical to understand notation. So like we did in the last section, or the last video, we had y equals 2x plus 3. We could represent that as a function f of x equals 2x plus 3. Now that meant that I was going to input x values and my output was going to be based on whatever this expression was. So I input an x value of 2 and my output came out as a 7. I input an x value of 0 and my output came out as a 3. All right, so you input the x's and f of x gives your output. So f is describing what essentially f of x describes what the output is. Now, in the previous part of this lesson, if we had a function, let's say f again, although it's not the greatest we're using the same letter, but that's okay. We dealt with this mapping type notation where we said, well, A is my input, and this arrow that's pointing to the right says that you input of A and you get out a 1. You input a B, you get out a 2. You input a C, you get out a 3. You input a D, you get out a 4. Now we can change that notation up by using the same type of function notation we did up here. F of x equals this. And you can do it on a finite scale too, meaning you can only deal with A's, B's, C's, and D's. You only have maybe, let's say, 4 inputs. And you can just list off, well, A, when you get input into the function, gives you out a 1. B, when it gets input into the function, gives you out a 2. C, when it gets input into the function, gives you out a 3. And D, when it gets input into the function, gives you out a 4. So these two things, this and this, mean the exact same thing, but we have different notation. And this is a little bit more sophisticated notation because it can allow us to deal with multiple functions, because we can have multiple, different letters lying around representing different functions. Now, also one other notation that you could encounter is the ordered pair notation. Again, this is kind of how we connect back up to what we did in the previous chapter. We had y equals 2x plus 3. We'd say, well, when we input an x of 2, we get out a y of 7. And we'd say, well, that means that the point 2 comma 7 is on this line. And so we can translate that into function notation by just saying, well, let's let all of our outputs be like y values. And so our inputs are going to be those x values, and our outputs are going to be y values. So if you input an A, you get out a 1. That's kind of this notation. If you input a B, you get out a 2. You input a C, you get out a 3, and D, and you get out a 4. So these are the 4 notations you're going to encounter. These 3, which are sort of finite, where you list out all of your inputs and all of your outputs. And then this type of notation, where your f of x gives you a formula. And so this kind of sets us up for domain and range. We're going to have finite inputs, and then we're going to have sort of infinite inputs. The infinite inputs are going to come in those formula shapes. or I should say those formula notations. All right, so let's take a function defined this way. So g of 1 is 2, g of 3 is 4, g of 5 is 6, g of 7 is 8, and g of 9 is 0. And we're going to ask for the domain and the range of this function. Well, notice that the only numbers that I've input into my function are 1, 3, 5, 7, and 9. And therefore, the domain is 1, 3, 5, 7, 9. It's the list of all of those numbers. Okay. By the way, this has a typo on it this word should say domain. So you can cross out range. The domain is the set of all inputs. Therefore, the domain is 1, 3, 5, 7, 9. And then the set of all outputs, well, the outputs are what these things are equal to. 2, 4, 6, 8, and 0. So the set of all outputs is the range 2, 4, 6, 8, and 0. Now, again, notice that we're not allowed, and because we only have a finite number of things I could plug in, I'm not allowed to input the number 23 because G only allows inputs of 1, 3, 5, 7, and 9 unless, otherwise stated, unless there's another part of G that we can't see. But the only things I'm told are the inputs of 1, 3, 5, 7, and 9. So those are the only elements, the only numbers in my domain. And the same thing, the only outputs are 2, 4, 6, 8, and 0. And so that's how we deal with finite cases. We just look at the inputs, look at the outputs. And I wanted to bring up these finite case notations just because on a test, on a thing, you can see any of these three notations and you should say, oh yeah, inputs are A, B, C, D, whether I'm looking at this notation, whether I'm looking at this notation, or whether I'm looking at this notation. So the domain is the set containing A, B, C, D. The range, obviously the outputs, 1, 2, 3, and 4. So inputs, domain, A, B, C, D. Outputs, range, 1, 2, 3, 4. Now, technically, the domain is a set. So if we were really strict, you say, well, the domain isn't just these numbers, it's the set of those numbers. So that's why you'll see set notations in the book, and the range, again, set notation. I'm not too worried about putting set brackets around stuff. I just want you to know domains the inputs, range is the outputs. Okay, so don't worry too much about the set notations. That's not something that I'm really particular on. Now, where it gets a little bit more interesting and a little bit more tricky is when we have, let me zoom in here, there we go, is when we have a function which is defined as f of x is equal to some formula. Well, we can ask, what's the domain? And that question is like saying, what can you plug in for x? Let's go and look. This is obviously f of x equals x plus 1. That's a linear function, just kind of like what we had here. So the question is, what could I have plugged in for the x? Well, the answer is you could have plugged in anything you wanted to. In terms of, obviously, we're dealing with numbers, so any real number you wanted to. So the domain for a function like this, since I can plug in anything, it is all real numbers. And by the way, there is a shorthand notation for all real numbers. That notation is this R with a lot of times when you write it by hand, you write two lines on the left-hand side. It's called a double R. It's an R inside of another R, basically. So all real numbers you can write this way. And by the way, the set of outputs in this case is also all real numbers. So the range, the set of outputs, is also all real numbers. Because you could have also plugged in anything for essentially your Y value, your output value. All right. And so let me see if I can double R. Yeah, there you go. All right. So there you go. Both the domain and the range on functions like this are all real numbers. So there you go. Now, let's take a look at this function, g of x equals 1 over x. Now, this is similar in that you can basically plug in anything you want into x. However, there's a problem with a denominator. And that problem is that mathematically we cannot divide by 0. So notice that when the denominator is 0, you get 1 divided by 0. That can't happen. Therefore, in this case, you cannot plug in 0 into your x value. So your domain for G is all real numbers except 0. Now, obviously, in other situations, let's take another example here. If I had something like, let's call it h of x this time, and it was 2 divided by, let's say, x minus 7, plugging in 0 for x is okay, because when you plug in 0 for x, you simply get 2 over negative 7. But it's not okay for the denominator to be 0, right? So in this case, it's not okay if x is 7. Now be very careful here. What does that mean about the domain? The domain is not 7. 7 is the only place which is not okay. So the domain is all real numbers except 7. All right. So be careful of that type of thing. When you have a fraction and you have a variable in a fraction, your domain is all real numbers except whenever that denominator is 0. By the way, this is also indicating that this is one of the reasons we like polynomials. Remember, polynomials we couldn't divide by variables. And so when polynomials exist, the domain is all real numbers. When I should say the expression f of x equals a polynomial, then the domain is all real numbers. So what I'd like you to do is I'd like you to push pause on this video and try the cooperative group problems in 3.5b. I'll go over those pretty quickly after you try them. All right, so sorry, I didn't scroll down. So in these cooperative group problems, we start out with number 1, given the function h described this way, what's the domain and range? Again, if you haven't done these, I want you to push pause and do these. I'm going to go through all of them in a real quick fashion here in just a minute. Just 5 seconds. All right, so here we go. Domain are my inputs. So my inputs in this case are 1, 2, 3, 4, and 5. Again, that's understanding this notation that h of 1, that means I'm inputting 1, h of 2 means I'm inputting 2, and so on and so forth. My range Well, the only number that things go to is the number 2, so my range is 2. By the way, you don't have to write 2 multiple times. You can just write range is 2, and that'll be good enough. All right. All right, given the function g defined as g of x equals 1 over 2 minus x, what's the domain? What I like to do is just say, well, it's not okay to divide by 0. Not okay if, in this case, dividing by 0 would cause my denominator to be 0. It would cause x to be 2. Again, the way you do that, solve that, add x to both sides. Not okay for x to be 2. So the domain, again, if it's not okay for x to be 2, the domain is all real numbers except 2. All right. Number 3, by the way, that doesn't ask for a range. I'm not going to ask you for a range on that, those types of questions. Given the function f defined by f of x equals 3x plus 5, what's the domain of f? Well, the domain, since there's no way to divide by 0, because all of my variables, no, I'm never dividing by a variable. So since I'm never dividing by a variable, I can't divide by 0. So my domain is all real numbers. Also, the range is all real numbers as well, but that's okay. This question doesn't ask for the range. Question number 4 is another finite example. It's another h of, and then we have inputs. The domain here, well, my inputs are 5, 6, 7, 8, and 9. So 5, 6, 7, 8, 9. Type that in. My range, well, my outputs are also 5, 6, 7, 8, and 9. So in this case, my range is the exact same as my domain. So inputs and outputs are the same numbers. Number 5 here, it says, given this function g, what's the domain? Now, again, the problem is going to be when the denominator is 0. So you can write not okay or problem when. So the problem is when the denominator is 0. Then I'd solve that equation and I'd say, well, that means add 1 to both sides of this equation. 2x equals 1. That's x equals, you can write it as 0.5 or 1/2. It doesn't matter as far as the answer goes. So there's a problem when x is 1/2. So that means that the domain is all real numbers except 1/2. Or again, you can write that as decimal 0.5. It's all the same. So all real numbers except when the denominator is 0. And then lastly, on these problems, function is 3x squared plus 2x minus 1. There is no division by any variables. In fact, this 3x squared plus 2x minus 1 is a polynomial, so no division by any variables. So the domain is all real numbers. And there you go. So that's how to find domain and the range.